Hello everyone, welcome to the Law of Sines and Law of Cosines review. As you'll notice, I put a couple of other videos out there on these topics done by a group on YouTube. Feel free, take a look at those. They are optional, but if you are struggling or have some questions or not quite getting one of the concepts, feel free to watch those. I think the longest one is about 7 minutes long. And just maybe sometimes hearing somebody else explain something, or maybe different words, or they have some great visual and graphics on there, they might kind of help really solidify some of these concepts in your mind, especially coming up for the quiz tomorrow. All right, so what we're going to do is we're just going to do a quick review of the law of sines, law of cosines, the ambiguous case, and then I'm going to do 4 problems from the review assignment just to get you started, okay? All right, so with the law of sines, all right, well, before this unit, you guys had talked a lot about triangles that were right triangles. You talked about how you could use the Pythagorean theorem. You talked about how you could use SOHCAHTOA to find missing angles, missing sides in those right triangles. Well, if you remember correctly, in this unit, we don't have right triangles. We have either acute or obtuse triangles like the one pictured at the top. And we can still find side lengths, we can still find missing angle measures in these triangles using the law of sines. Now, in order to use the law of sines, what you first need is a matched pair, right? You need a matched pair. So if I want to use the law of sines, I better have this side, or that angle, and this side. Or I need this angle and this side. I need some sort of matched pair in order to fill in one of my proportions. And then what I can do is if I've got, say, this side, I can find that angle. I could plug in that side to find the angle. Or if I had this angle right here, I could use that to find the side straight across from it. Okay, if I had this angle, I could fill in and find the side. So we need one matched pair, then just one of the other bits of information from the thing that we're trying to find. Okay, now remember, we talked about this a little bit yesterday. Use this formula to find all of your missing angles. Avoid the triangle sum theorem unless they give you 2 out of the 3 angles right away. If they give you a triangle and they tell you that one of the angles is 80 and another one is 70, you can be confident that the last one is 30. Don't worry about it there. But if it is one where you've only been given one angle and you're being asked to find the additional 2, use the law of sines to find all 3. Then when you get to the end, add them all up. Okay, add them all up and see if you get 180 or reasonably close to 180 degrees. If you haven't gotten 180 degrees, then what you're going to want to look for is the longest side and the angle associated with that longest side. Likely what's happened is you've been given the acute measure for that angle when you really want the obtuse measure for that angle. So what you would do is you would just take 180 minus, and I'm going to use the little star just like I did up here to represent that, minus whatever you did get for that angle, and that should give you the angle that you want. Okay, we talked about that a little bit yesterday. All right, moving on to the law of cosines. The law of cosines, again, is for when you don't have a right triangle, and now it's when you don't have a matched pair. So maybe you've been given a side angle side scenario or a side scenario. You don't have any angles that line up with a side that you've been given. That's when you're going to use the law of cosines. And this comes down to 3 different equations. Okay, we had 3 different equations for the law of cosines, but they all pretty much say the exact same thing. And what you want to look for is, if you're looking for either side A or angle A, you're going to use that top equation. If you're looking for side B or angle B, you'll use the middle, or side C or angle C, you're going to use the last. Basically, if you're looking for whatever angle or side you're looking for, you're going to look for the equation that has it on the outside, not on the inside. Okay, the inside stuff you should be given, you just be able to plug in. All right, that's our law of cosines, and is really just a larger calculation. It looks messy, but the calculation isn't too bad. That's when we get to our side-side angle ambiguous case. And remember, side-side angle is an ambiguous case because this was not one of our triangle congruence rules. And it wasn't because we didn't know which of the two triangles it was potentially talking about. So we could have two triangles that have a same side, and then an angle, but they're two completely different triangles. So what happens when we get this particular case? First step, check if the angle given is obtuse or acute. Okay, so you're going to be given at least this angle right there. Check and see if it's obtuse or acute. If it's obtuse, you're going to be looking at the two scenarios on this side. If it's acute, you'll be looking at the four scenarios on this side. Then, if it's obtuse, you just compare side A and side B. The side across from your angle is A, the side that's next to your angle is B. Compare those, you'll either get no triangles or one triangle. If it is acute, we need to find the height of the triangle. We need to find the height of the triangle, and there's our equation. Height is equal to side B times the sine of A. And when you're looking at this, and we'll see it in an example, this you can figure out even if it's not an A or even if it's not a B. We'll take a look and see how we can figure that out, even if it's not matching up directly with A and B. But the idea is the sine of the angle you're given times the side that it is attached to. Okay, so once we find the height, then we are going to go through and we are going to see which scenario does this fall into. Is the height bigger than side A? Is the height equal to side A? Is the height smaller than side A, which is in itself smaller than side B, or is side A bigger than side B? So those are the different scenarios that we're going to be looking at. So let's take a look right away at one of those. Okay, so from our review worksheet, 10.4, the law of sines. It's that first review that I believe I put in the PDF. Here's what I've been told. Angle A is 46, perfect. I'll write that there. Side A is 12.5, and side B is 10.2. Here's what I want to do. I want to first, since I know this is acute, I'm going to get rid of the obtuse side. Okay? First question, obtuse or acute? Since it's acute, I'll just get rid of those so they don't confuse me. Since I'm on the acute side, though, I know I'm going to need to figure out the height of this triangle. So here's what I'm going to do. I'm going to find the vertex that is right in between the two sides that I've been given. Okay? So if I had been given this angle instead, and these, and these two sides, I'd be using this as my vertex. Basically, just find the vertex in between the two sides that you've been given and drop an altitude down from that vertex. There we go. All right, now there's my height. Okay, so now I've created this smaller right triangle right there. Now I can use SOHCAHTOA to find the height. So I don't want you guys to panic on this. Just drop that vertex, drop the altitude from the vertex that's right in between the two sides you've been given. And now, using the SO part of SOHCAHTOA, the sine of 46 degrees is equal to opposite over hypotenuse. Well, the opposite thing here is the height, right? Straight across. And the hypotenuse of this triangle, the long side, is 10.2. So 10.2 times the sine of 46 degrees is equal to h. I just multiplied both sides by 10.2. I can grab my calculator. And I get that the height is equal to 7.3. Okay. There we go. All right, so now on this type of question, it's just asking how many triangles can actually occur based upon what we've been given. So now here's what I'm going to do to make my life easier. I'm going to go over here and I'm going to write these in order, okay? So H looks like it is the smallest. The next is B. and then the next is A. So all I did is I just jotted these three things down that I had found from smallest to largest. Okay, so now it's going to be really easy for me to look through this. All right, is H greater than A? No. Is H equal to A? No. Is H the smallest? Good. Then A? No. Actually, A is bigger than B. So we know that's not the case. So the last thing we see is A greater than B? Well, in this case, it is. A is 12.5. B is, 10.2. This must be our scenario. So how am I going to write this? Well, given all this information up there, then we know that one triangles are possible because the triangle is acute and A is greater than B. So basically just take the bits of information that you see here. One triangle is possible because A is acute and A is greater than B. Okay? So that's how I'd ask you to do those types of problems. Now, there's a different type of problem where they're actually telling us that there's two possible ways and asking for both of the different options for angle B in this case. All right, so let's draw our triangle. Okay, so we'll go A, B, C. A is 54 degrees, side A, side B. Okay, so again, this, not surprisingly, is a side-side angle type of scenario. Is the angle obtuse or acute? It is acute, so I'm going to get rid of the obtuse right away. Since it is acute, I know I'm going to need the altitude, so I'm going to look at my two sides, pick the vertex right in between those two sides, and drop an altitude down. Okay? And in doing so, I have created this right triangle. Now I can find the height. Here I don't have to necessarily find the height, but I think it'll be good practice for us just to see. Okay, so height is going to be equal to the sine of 54 degrees times the hypotenuse, which is 8.2. So height, sine of 54. We get 6.6. If I were to come back over here, put these in order, height is the smallest, A is in the middle, and B is the largest. So is height bigger than A? No. Is height equal to A? No. Height, then A, then B. That looks promising, but let's just double check. A is greater than B? No. So I know this one has two triangles, which makes sense because it's asking for what the two possible measurements for angle B would be. Once we know that, we just use our law of sines because we do have a matched pair, right? We have angle A and side A. So the sine of 54 over 7.3 is equal to the sine of whatever angle B is over 8.2. We will cross multiply. And we'll divide both sides by 7.3. So I know the sine of B. Now let me just pump this into the calculator. And I get 0.908. We'll go to 6. And to get rid of the sine, I'll do the inverse sine of both sides. So I get that angle B is equal to 65.3 degrees. So that is my first option for what angle B is going to be. All right, now if we remember correctly, to find the other option is pretty straightforward, it's pretty easy, and it's based upon this concept. Well, we need to have a 54-degree angle. Let's use my highlighter here. We need a 54-degree angle. We need this side to be 8.2, and we need this side to be 7.3 because that's what we've been given. But what this side can do is swing in the other way. Okay, that 7.3 side can swing out or it can swing in, creating this much smaller, skinnier triangle in here. That's our second potential triangle. But it also makes a triangle that we didn't even really attempt to make right here. It created an isosceles triangle right there that has 7.3 and 7.3, and I know that this angle measure is 65.3. So remember how we talked about, well, if that's 65.3, then the other base angle of our isosceles triangle is 65.3. So when we go to look for this angle right there, bad color, when we go to look for this angle right there, we know it's just going to be 180 minus 65.3 because, excuse me, it is supplementary with that. So, what is that? 180 minus 65.3. No, 114.7. So the other option for that angle is 114.7 degrees. Those are my two options for angle B. Okay, and you don't need to go through the whole isosceles triangle analysis, but if you forget and you're stumped, how do I find the second one? Use that to jog your memory, or you can just say 180 minus the triangle that you found is going to be equal to the other possibility for the angle. All right, switching over to the worksheet that says law of sines, law of cosines, and it's kind of handwritten on there. Let's take a look at number 5. All right, number 5, I don't have a matched pair. I have this side, or this angle, and that side, but I don't know what x is. That's what I'm trying to find. And I don't have the angle that goes with either 9 or 12. So this must be a law of cosines question because I don't have enough to be able to use the law of sines. So here I'm just going to label this triangle so I can pick an equation to keep everything straight. All right, so I've made it, so I'm looking for side A. Okay, so that means that I'm going to want to use the equation where the a squared is on the left, the other are on the middle, minus 2, and the angle A is on the far right. That's the one I'm going to want. The thing that I'm looking for, I want to be on the outside. Since I'm looking for side A, I want the one that has side A on the left and angle A on the right. Now it's just a matter of plugging in the values. Well, a squared, I'll just put it in as x squared because that's what I'm looking for. And fill in all of the other values just as they appear on my triangle here. Okay, now it's just a matter of doing a lot of calculations. And because I have a graphing calculator, I'm just going to type these all in at once. If you're using a non-graphing calculator, no problem. You just solve it as you normally would. Do your 9 squared, do your 12 squared, and then you should be able to do 2 times 9 times 12 times the cosine of 120 all at once. All right, so I get that x squared after all of those calculations is equal to 333. I want just plain x, not x squared, so I'll take the square root of both sides. So x is equal to 18.2. All right, so fairly straightforward. Oops, didn't mean to do that. Fairly straightforward. I just did my used my law of cosines, did my calculations, and was able to find that side A or X is equal to 18.2. One last thing that I would just double check on this one is to make sure that since A is such a large angle, I want to make sure that side A is bigger than both of the other sides, and it is. If I had gotten a value for X that was smaller than 9 and 12, then I'd probably want to be double checking. Okay. Last one I'm going to go through is number 8. Now you'll notice number 8 on that worksheet, we are given side angle. So we are squarely in one of those ambiguous case type of problems. So I want to figure out, is this one triangle, two triangles, or zero triangles? So what am I going to do? First step, I'm going to look at that vertex that's in between my two sides, and I'm going to drop an altitude down from that vertex. Okay, so now I have created a 90-degree or right triangle right there. Okay, here's the angle I'm working with. Here's the hypotenuse of that 90-degree triangle. So I know height is going to be equal to the sine of 25 degrees times 12. Well, let's do that. So now I know my height is 5, we'll go 5.1. Okay, so I'll line them all up again. Height is 5.1. I'm going to label that A because that's what we're used to, having the angle be A. I'm going to label that B because that's across from side B. And so this must be side A and side B. So next would be side A is 9, side B is 12. All right. Is H bigger than A or equal to A? No. And feel free to look at your notes on this. And is A greater than B? No. So I know this is the one where I have two triangles. And you'll be able to use that portion of your notes on the quiz. I don't want you trying to memorize all those different scenarios, but you'll be able to use that portion. All right, so now I've confirmed I do absolutely need to find two triangles. Well, now that I know that I need two, easy enough, I'll just use my matched pair. And determine what angle B is. So I'm just going to use the X over 12. I'm trying to find these two. So I will cross multiply. And divide both sides by 9. All right, let's plug this in. And since I'm down to the sine here, let's do the inverse sine of both sides. So angle X is equal to 34. We're on to 3. All right. So one potential value for X is 34.3. We don't need to do the whole analysis again, but to find our second, we'll just take 180 minus our 34.3, which gives us that the other potential value is 145.7. All right, that concludes the ones that I want to go through. Please finish the rest of those. They're definitely going to be helpful to you. I will have office hours as I put in my announcement, so if you have any questions, please feel free to ask. And if you are struggling with any of these, I do recommend just checking out those YouTube videos. Like I said, I think one's about 5 minutes. One is, I think two of them are about 5 minutes and one's about 7 minutes, so they don't take that long. And maybe that will just kind of solidify it or give you a little bit different perspective on it. Otherwise, have a great day, and you'll be taking your quiz tomorrow.